We're doing multiplication. So multiplication definition is you have a bunch of groups of the same size and you add up or count the content of the groups. So let's do a word problem. Hannah has 1,204 bins. Each bin has 2,379 pencils in them. How many pencils are there altogether? So we can set this up vertically as shown here right now. So we have 2,379 times 1,204. So this represents the pencils that are in the number of bins. You have a bunch of groups of the same size. So that would be 2,379 pencils, the same size. So let's do this problem. And we can set this problem up into sub-problems because we're working with 4 different units: singles, rods, flats, and supercubes. So we can start by multiplying everything by the singles. So we have 9 times 4 would be 9 singles times 4 singles, which would give you, split that up into 3 rods and 6 singles, and you carry that 3. And you have to split it up because since we are in base 10, you can't go above 10, so you have to put the 6 here, carry the 3, and split that up into singles and rods. Alright, so now we have 4 times 7, which would give you 28 rods plus 3 rods, which, to split it up, since we're in base 10, we have 3 flats and 1 rod, and carry that 3 over. Now we have 4 times 3, which is 12 flats plus 3 flats that we carried over, which would, since we're in base 10, we have to divide that up into 2 different units, so it would be 1 supercubed and plus 5 flats, and carry that 1 over, which would give you this first line of answers. Now, and then 4 times 2 would be 8 supercubes plus 1 supercube, so that would be 9. So we can put this 9 right here because we're in base 10. We're not going over. Now we are moving over. This is a big step. We're moving over 1, so we put the 0 right here to represent that we are now moving to the rods place, or the tens place, because we multiplied everything by this 4 because we're in 4 different units. So now we are multiplying everything by the 0, or this would represent 0 rods. So now, multiply everything by 0, which is pretty easy because the answer is all 0. So now we're moving on to the third column, and we move over 2 spots. Why? Because now we are on the flats place, or 2. This would be like multiplying all these numbers by 2, and we are dividing this up to sub-problems because we're working with different units, 4 different units: 9 singles, 7 rods, 3 flats, 2 supercubes, times 2 flats. So 2 times 9 is 18 flats. Since we're in base 10, we have to divide that up into 2 units, so 1 supercube plus 8 flats. Have that A right here. We have 2 times 7, which would give you 14 supercubes plus that 1 supercube that was carried over, to give you 15 supercubes. Carry that 1. Now we have 2 times 3, which is 6 super rods plus that 1 rod that was carried over right here, to give you 7 super rods, and it fits in base 10, so we don't have to move or carry anything over. And then we have 2 times 2, which is 4, which would just give you 4 super flats. Now we're moving over again 3 spots. So we're moving over because since we multiplied everything by first by the singles, then by the rods, then by the flats, now we're multiplying everything by this 1 supercube because we're in the 1,000ths place. So now 9 times 1 is 9, 7 times 1 is 7, 3 times 1 is 3, 2 times 1 is 2. So now we have these 4 columns of answers. Now we have to add up all these groups, because if we go back to the definition, you have a bunch of groups of the same size, and you add up or count the content of the groups. So we have 4 different groups right here from multiplying everything by these different units. So we have to add them up. So 6 times 0, 0, 0, 6, and 1, and this would be 13. Carry that 1 again, so we're in base 10. And this would be 34, carry that 3. This would be 17, carry that 1, 8, and 2. So the final answer is 2,874,316. Now, to answer the question of why this works, why do you get the right answer? So we can divide up the problem into subgroups. Because we're working with multiple units. We have singles, rods, flats, and supercubes. So since we have more than one unit, we have to divide that up since we are in base 10 and carry those answers. And each unit is separate and then added together to get the product. So now for division reassessment. So we're going to do partitive division. So the definition is when you start with some things, give an equal amount of things to a fixed number of groups, and count how many things end up in one for each group. So we're using partitive because rather than handing out one cookie at a time, one cookie at a time, it's easier to divide it up into bigger groups than doing here's one, here's one, here's one. It's easier like here's 10, so you get rid of it faster. And it works. Alright, so word problem. A school has 2,890 cookies. If there are 34 classrooms, how many does each classroom get? So to go back to the definition, you start with some things, give an equal amount of things to a mixed number of groups. So we're giving an equal amount of things to, equal amount of things to this group, 34, 2,890 cookies. So we're trying to figure out how many does each classroom, these 34 classrooms, get. So I wrote it out up here, but we'll do it again. This is how you set up the problem, 2,890 divided by 34, classrooms and then cookies. So we can figure out how many times does this number go into this number. So since we are working with 4 different units, we have singles, which is 0. We have rods, which is 9. We have flats, which is 8. And supercubes, which is 2. So we are going to divide up this problem into different mini problems or sub-problems. Because since we are working with 4 different units, we can't all divide this by this big number right here. We have to divide up into multiple steps to get an accurate answer. So we need to find how many times does this 34 classrooms go into these cookies. So the number 34, how many times, we're going to start with supercubes because we're in 4 different units. How many times does 34 go into 2? That would be 0. So we can put this 0 up above because we are working right here. This is going to be our answer because this is saying that 34 times 0 is 0. Alright? So we can put that 0 there. Now, how many times is 34 going to 28? Since 34 is bigger than 28, you can't go into it anymore. We have 0 again. So 0, 0 times 34 is 0. Alright, now, how many times, since we are working with the 3rd unit, or the rods. So now we can put these 3 numbers together to get 289. Alright, so you would then be in the flat spot. So how many times does 34 go into 289? Now if you did this, 34 times 8 should give you 272. So that would be 8 times because that's the closest number. So now we can erase these because we are working with the hundreds place. So we have 272 and we subtract to see how many things end up in this group. So how many times, so that would be 9 minus 2 is 7, 8 minus 7 is 1, so 17. Now, how many times is 34 going to 17? 0, right? So we have to bring this 0 down to get a bigger number. So now we're in the flats place again. So how many times is 34 going to 170? We did 34 times 5. You get exactly 170. So that works perfectly. So we can bring this 5 up here. That's saying that 85 times 34 is 170 to give you 0. So we can equally divide 85 cookies to each classroom, each 34 classrooms, to give out 2,890 cookies. So to go back, we started with some things. Give an equal amount of things to a fixed number of groups. So 34 groups, give equal amount of things, and count how many things end up in each group. And that answer would be 85. Since we are working, this works. Why? Why does it work? Because we are using 4 units. And we can divide this problem up into multiple steps. We have this step and this step. And we slowly figured it out that by working with each unit, you can figure out the problem. First with the first unit, second, third, and fourth to get the right problem. Thank you.